Hey everybody, in this video we're going to talk about transformations. So a transformation of a figure, line segment, or any kind of shape or item is the change of location or size of a figure. Now there are three types of transformations where if you take a figure and you can move it, or you can spin it, or you can flip it, where the size and shape of the figure does not change. So the original image and then the new one would be the exact same in terms of size and shape and not orientation, but just the way it looks. Okay? So the first one we're going to talk about is translation, excuse me. And a translation is if you have like a triangle, let's say it's on the coordinate plane, and all we do is we slide the triangle across the x-axis, along the x-axis, and then we will draw another triangle. That would be a translation. So all we're doing is we're sliding the triangle from one spot to another. The second type of transformation is called a reflection. And a reflection we see and encounter something like this every single day when you look in the mirror or when you see yourself in the window, like the backlight shows and you can see your reflection on it. So in geometry it's the same idea. So if we have a triangle, and let's say we're going to reflect it about the x-axis, or a little bit above it, so x equals 1 is our line of reflection. So then the same image will be flipped over that line, the same distance. So if we have our triangle, the base of it at least, start at 1, 2, 3 units above the axis of symmetry, and if we flip it, we're going to start 1, 2, 3 items or units or squares below that line of reflection. Okay, so it's a mirror image of each other. Now the third type of transformation is called a rotation. Okay, so that's our spinning. So if we take the same object and we spin it counterclockwise, which goes this way, or clockwise, which is this way, the image does not change size or shape. So if here we have our triangle and we're spinning it counterclockwise, our image is rotating, or our triangle is rotating about the origin, and it should look like this. Okay? So these are all types of rigid motions. And rigid motion transformations produce congruent figures. So if you look, translations, we have the same triangle just moved over to the left, the same triangle in a reflection just mirrored over this line of reflection, and then our rotation of a triangle is just spinning counterclockwise. So in example 1 we're going to use a rigid motion. So it says graph the points A, which is negative 5, 2, B, negative 3, 2, C, negative 1, 5, and D, negative 3, 5. We are going to reflect this image in the y-axis and identify the new coordinates of the image, A prime, B prime, C prime, and D prime. Okay, so let's graph our points. We have A at negative 5, 2, B at negative 3, 2, C at negative 1, 5, and D at negative 3, 5. So we connect all our points, so we have a quadrilateral, and we are going to reflect this quadrilateral in the y-axis. So our line of reflection is going to be the y-axis. So we're going to draw our line of reflection. So kind of we have a guide just to look at, so to make sure that yes, we are actually reflecting about this line, and the distances that we need will be exactly the same on the other side. So using the line of reflection, we're going to go one point at a time. So we're looking at A. So A is 1, 2, 3, 4 points. 1, 2, 3, 4, 5, 5 points to the line of reflection. So in the opposite direction, going across the line of reflection, we're going to go 5 points. 1, 2, 3, 4, 5. This is where A prime should be. Okay, so we do the same thing with every point. B, we're 1, 2, 3 units away from the line of reflection. So we're going to go 1, 2, 3 for B prime. Same thing with C prime, which is 1 unit away from the line of reflection on the other side. And D prime will be 1, 2, 3, so 1, 2, 3. there's D prime. So we connect our quadrilateral. So look how the original image of ABCD has been reflected in the y-axis. So we have a mirror image of the original figure. So our image of A prime, B prime, C prime, A prime, B prime, C prime, D prime looks exactly the same, but on the other side of the line of reflection and just flipped. So now we have to identify what the coordinates are. So we have A prime, B prime, C prime, and D prime. A prime, we're at, if this is our origin, we're at 1, 2, 3, 4, 5, up 2. So we're at 5, comma 2. B prime, we're at 1, 2, 3, 1, 2, 3, 2. C prime, we're at 1, 1, 2, 3, 4, 5, 1, 5. And then D prime at 1, 2, 3, 1, 2, 3, 4, 5. In example 2, we're going to identify congruent figures with the different components that are corresponding and that are congruent based on our diagram. And there are going to be a lot of symbols and notations that you have to recognize that will tell you what angles or what sides are going to be congruent. Okay, so it says the figures below are congruent. Identify the following: all pairs of congruent angles, congruent pairs of sides, and the congruent statement. So let's first identify all of our congruent angles. Now, besides the fact that you have color that matches angles to angles, I want you to pay attention to how many angle marks we have. So the first pair that we can talk about is angle Q and angle J. So besides the fact that angle Q and angle J are both marked with green in the notes, we can see that there's one angle swoop by angle Q and one angle swoop by angle J. That lets us know that those two angles are congruent without giving us an exact measurement. The fact that we have that one angle swoop in both angles or on both angles lets us know that they are congruent. They're the same measure. Whatever that measure may be, they're the same. So second pair, we have angle P and angle L. They both have 1, 2, 3 angle swoops. 1, 2, 3 angle swoops. Okay? It doesn't mean it's 3 times the size of angle J. It just means that, hey, angle L and angle P are the same measurement. The last pair, angle R and angle K. So these two angles have 2 angle swoops and 2 angle swoops. So now we have to identify all congruent pairs of sides. So if you look at the markings on the sides of the triangles, we have little dashes that are called tick marks. That also lets us know what sides are congruent. That's going to be very beneficial for us when we actually have to use congruent triangles or figures to determine the actual lengths using algebra. So one first pair of congruent sides would be PR and LK. PR has one tick mark and so does LK. So notice how I actually started with angle P, which is red, to R, and the correct notation, if I'm identifying PR as one of my sides, well, my corresponding congruent side would be LK. A second pair would be QP and JL. So QP goes from green to red. They both have 2 tick marks. JL, red to green, or I'm sorry, green to red. And then our final pair is RQ is congruent to KJ. So this little equal sign with a little squiggly line is called a congruent sign. It lets you know that the measurements are the same. We don't know what they are, but whatever they may be, they're the same. They're not, so if you look at PR and LK, it's not equals, it just means that there are 2 of the same sides that have the same measurement. So the last thing we have to identify is a congruent statement. Our congruent statement could be written 3 different ways, and it doesn't matter which way you choose, but you have to make sure that the order of the vertices that you name the triangle, is the same as the order of the second triangle. So for example, if I say for my congruent statement it's going to be triangle PRQP, so I went from R to Q to P. So if you didn't have colors, or if you have colors on your worksheet, which I don't think you will ever, you go from blue to green to red. So then that means I have to go from blue to green to red. Or you can look at the tick marks or the angle marks. So the tick marks, I can go 3, 2, to 1. So then I would look at my sides where I go from the 3, which is right here, 3 to 2 to the 1. Okay? So then my congruent triangle that matches with triangle RQP would be triangle KJL. Okay, so we didn't have to start necessarily at R. We could have gone from P and gone to Q to R, or we could have gone from P, R to Q, but just make sure that however you track the triangle along the sides, you're doing the same thing with the second triangle or third triangle that you're making your congruent statement with.